All right, so this video is on standard error of the mean, and I'm going to try and crank this out in under 10 minutes. So when we do bar graphs and when we have data and we're trying to see if one population is different from another population, we often make these bar graphs, but the whole idea of presenting data is to make conclusions easier to make. So if you had the question, do men or women have greater forearm muscular endurance? And this is just a little lab we do in freshman bio to generate a lot of data. We could look at this and be like, okay, we have this graph, which is kind of what Google Sheets gave us for the scale. Be like, oh yeah, men have way greater forearm muscular endurance than women. Look at how much bigger this bar is. But if you change the scale, these bars get much closer together. So what kind of conclusion do you actually make, and how does that conclusion become significant? So if you're going to say, the data suggests that men have greater forearm muscular endurance than women, how confident can you be in that conclusion? And just by saying this bar is bigger than that bar, or this bar is bigger than that bar, or these bars are really close, so maybe it doesn't matter what gender you are, there are statistical ways to make a little bit better conclusions. And one of those is to do this standard error of the mean. And what you end up with, and you can do these on sheets, where you have these extra bars hanging off, and if they overlap significantly, there isn't a big difference between the populations. So we're going to talk about how to do the math to figure out what these values are, and then how to put those onto a graph on Google Sheets. So if we take a look at some data, first of all, if you're going to make a bar graph instead of a box and whisker, your data should be normative, which means it should fit a bell curve. So the first thing when doing standard error of the mean, you don't want to do it with just like 2 data points. You should have, and the golden rule of statistics is about 30, a sample size of 30, to be able to do some of these other statistical analyses. And we have over 30, and then we can also, highlight this data and do a quick histogram look to see if it follows a basic bell-shaped curve, which for the most part it does. So doing a mean in this case is okay. If we did not have a bell-shaped curve here, you'd be looking at doing box and whiskers and medians, but this looks all right, so we're going to go with it. Okay, so the first step here is to find the mean, and we can do a simple average function here. So we're going to average all these numbers. And there we go. So the means of these two are different, and those were the heights of the bars on that other graph that I showed you. Now, we need to do a standard deviation function, and in that bell-shaped curve, the idea of one standard deviation, it will tell you how much of the data falls within a certain distance of this mean. So again, we're not going to get into exactly what all of these things mean. I'm just going to show you how to do the functions, how to do the math on sheets, and how to make the graph, and then we can talk about what those bars mean. So we do have this ability to use a standard deviation function. So it's STDEV is the name of the function. So if you put an equal sign, you can automatically prompt statistical functions, and I'm going to do standard deviation. And with standard deviation, again, it works the same way. You highlight the data that you want to find the standard deviation of. Okay, so we have these two standard deviations. Now we get a little bit trickier. And we need to find the standard error of the mean. It is a mathematical formula where you take the standard deviation divided by the square root of the number of samples. Okay, so what that looks like here. Again, we are going to do a mathematical formula here. So we put in the equal sign, which prompts Google Sheets to do the math for us. And again, it's the standard deviation, which is this, divided by the square root of the number of samples. Okay, so we take the standard deviation, we put the little divided by sign, and then it's going to be the square root. So we can do the square root function. So that's this SQRT right here. And then it's the square root of the number of samples. So I can take, okay, there's 69 minus 1, but another function that you can do is just put in a count function. And then if I highlight all this, it's going to get the number of samples, and it just stops me from making mistakes. So I click that in, and it gives this standard error of 7.94. Okay, I'm going to do the same thing over here. Equals, I'm going to do the standard deviation divided by the square root of the number of samples. And again, we tested more women than we did men in that freshman class, so the number of samples is not the same. I click that. Oop, I messed that up. I didn't put in the count function, so let me try that again. Equals standard standard deviation divided by the square root. Then I gotta put in that count function of all the, and again, it's not putting in these numbers. What it's putting in is how many actual people there are, the number of the sample. And that gives us this 7.33 as our standard error. Okay, so now we're also going to talk a little bit about a 95% confidence interval. Because when you put these bars above and below the mean on your graph, what you're going to see is that 68%, you have a 68% chance that if you chose another person at random, they would fall within that range of the mean. And the confidence interval, though, is a greater spread of the data, or the longer the bars extending, the more confident you could be that a sample of a new population our sample would fall within the true mean, or what the true population actually is. Okay, so to do this, we are going to double the standard error. There we go. So from here, we're going to make a graph. So we have men and women. And the graph is going to be of our means. That's the height of the bars. And I'm pasting special here values only so that just these numbers go across and we don't get errors because these are functions. So I highlight what I want to graph. I hop over here. I want to make column graph, and I'm all good. I can hop over here. I can put my legend on the bottom. I can change some of this, and again, we have the chart title. I think I'm running a little bit low on time here, so we know how to put in our labels. So I'm going to have to demonstrate this on another video as far as actually putting the bars on. So to be continued.